Problem set 1, drag race. A car accelerates at 15 meters per second squared down the entirety of a 120 meter track. The car has a mass of 750 kilograms. After crossing the finish line, the car stops accelerating and puts on its brakes. It slows to a stop by friction. Coefficient of kinetic friction equals 0.7 between the tires and the road. How long will it take the car to complete the race, cross the finish line? So for number 1, we're asking for a time when we're given an acceleration and a distance. The equation that uses TA and delta x would be that delta x is a over 2 t squared. So filling in, actually I'm going to solve for t first. T is equal to the square root of 2 delta x over a. All right, so that's going to be t equals square root of 2 times delta x over a. 2 times 120 divided by 15, square root 4.0 seconds. Okay, number 2. What will be the car's max speed? We're looking for a velocity. The time, the values we have are a time. We've got an acceleration. We also have a distance. I suppose the simplest way would be to use these 3 because they are related in this equation. If I wanted to use that, I suppose I could use this equation. But this looks more complicated. I'm going to go with that. So solving for velocity would be multiply both sides by t. Acceleration is 15, delta t is 4, so that would be 60. Number 3. How much force does the car's engine output to produce its acceleration? Being asked for a force, we're given a mass, and we're given an acceleration. They all fit in this equation, which when you substitute in these values, 750 times 15, that will be the force. 750 times 15 is 11,250 newtons. Okay, number 4. How far past the finish line will the car go as it slows to a stop? Okay, so this is going to be after it finishes the race and as it's slowing down. So I'm being asked for delta x, and if I'm going to get a delta x, I'm going to need something like a change in velocity. That I have. The change in velocity is it's going to slow down from 60 to 0. So the change in velocity is negative 60 meters per second. If I'm going to do x and v, I could be using this equation, but then I would need an acceleration. I don't have an acceleration, so how can I get one? I'm going to have to get it from the friction. So that acceleration, the deceleration, is going to be from the force of friction. Force of friction is coefficient of friction times the normal force. In this particular case, that normal force is going to be the weight. So let's get the weight. If the weight is mg, that would be the mass of the car, 750 kilograms, times gravitational acceleration, 9.8 meters per second squared. Here's how much the car weighs, 750 times 9.8. It weighs 7,350 newtons. So that's going to be the normal force. So the force of friction is equal to the coefficient of friction, 0.7, times the normal force, 7,350. 5,145. So that's the force. Okay, so if the car is being caused to change speed, that is slow down, with a force of 5,145 and the mass is 750, then the acceleration can be solved for. Just divide both sides by 750. 6.86. I suppose that should be negative because it's slowing down. Okay, so what am I looking for? A delta x, I have a delta v, and now I have an a. So I'm going to put them into this equation. V squared equals original v squared plus 2a delta x. Okay, the final speed will be 0. The original speed was 60. And the acceleration is, the acceleration is negative. So this is minus 2 times 6.86 times that delta x, which is the thing we don't know. So solving for delta x, let's see, that times 2, 13.72. So 13.72 delta x equals 60 squared. 60 squared is 3,600. So divide both sides by 13.72. 262.4. I guess that should just be 262. Okay, number 5. How long will it take the car to stop after it crosses the finish line? We're looking for a delta t. How long will it take? The delta x is 262. The delta v is minus 60 because it slows down by 60 meters per second. And the delta, and the a was negative 6.86. See, I think the simplest equation would probably involve these three. So I'm just going to take this equation again here, that one that I had already solved for. T is equal to the square root of 2 delta x over a. That would be the square root of 2 times 262 over 6.86. I guess I'll just be ignoring the negative here. And so that would be, let's see, times 2 divided by 6.86, square root 8.7 seconds. All right, there's problem set 1, drag race. Problem set 2, knocked off a cliff. Got 2 objects, both 12 kilograms. object A runs into it while going 20 meters per second. So let's see, I've got mass of object A, that's 12 kilograms. Velocity of object A at the beginning is 20 meters per second. At the end, it's 0. We got mass of object B, that's also 12 kilograms. The velocity of object B at the beginning, it started sitting, that's 0. And the velocity of B after would be actually unknown. So if we put this into our conservation of momentum equation, and fill in the values, MA is 12, 20, 12, 0, 12, 0, 12, unknown. Okay, simplifying, 12 times 20 is 240, that's 0. 12 times VB2. Okay, divide both sides by 12, we find that the final velocity of object B is 20 meters per second. What was the velocity of object B immediately after the collision? Well, there it is. Okay, how long does it take object B to fall to the ground? It doesn't matter whether it was knocked off or dropped off. Falling 250 meters is going to take the same amount of time. So if we're looking for a how long does it take when you're falling 250 meters and your acceleration is from gravity, which is 9.8 meters per second squared, then the time is going to be the square root of 2 delta x over a, and that would be 2 times 250 over 9.8. So the square root of 2 times 250 over 9.8. 2 times 250 over 9.8. Take that square root. It is 7.1 seconds. That's how long it takes to fall. How far away from the base of the cliff does object B land? Well, it has 7.1 seconds to move laterally 20 meters per second. So how far? I've got a how fast and a how long. These all go into this equation. So multiplying them together, 20 times 7.1 is 142. Oops, kind of circled the 1 off there. 142 meters. There we go. That's problem set 2. Problem set 3, this circuit. Find the voltage, current, and power for each resistor in the circuit. Okay, these two are in parallel, and that group is in series with that. So let me just redraw this. Resistor 1, that's 5K, and then this will be resistors 2 and 3 together, and that's going to be, well, I guess that's a bad way to write it. There we go. Okay, so that's 1 over 5,000 plus 1 over 10,000. I suppose this would be 2 over 10,000. So we've got a total of 3 over 10,000. And that means that the final resistance would be 10,000 over 3. 10,000 over 3 is 3,333.3. Okay, and so that means that the total resistance for this circuit is 8,333 ohms. That's the total resistance for this circuit. Oops. Okay, so that means that resistor 1 out of the total resistance being 5,000 out of 8,333, 5,000 out of 8,333 is about 0.6. And resistors 2 and 3 out of that total, well, they just have to be 40%. It's the only percentage left of them. So that means that resistor 1 is going to get 60% of the voltage. 60% of 9 volts is 5.4 volts. 40% would be 4 times 9, 3.6 volts. So this gets 5.4 volts. They both get 3.6 volts. Okay, well, I guess I can make a chart now. Resistor 1, resistor 2, resistor 3, voltage, current, power. Okay, the voltage for resistor 1, 5.4 volts. Resistor 2 and 3 are both 3.6. All right, now if Ohm's law says V equals IR, that means I equals V over R. So in order to get the current, I just need to divide this voltage by that resistance. 5.4 divided by 5,000. 0.00108. Okay, for resistor 2, that'll be 3.6 divided by 10,000. 0.00036. All right, and for resistor 3, that'll be 3.6 divided by 5,000, and that would be 0.00072. All right, and power by Joule's law is current times voltage, so I'm just going to multiply those numbers across. 5.4 times 0.00108. That's 0.005832 watts. Okay. 3.6 times 0.00036. That's 0.001296 watts. And lastly, 3.6 times 0.00072. That's 0.002592 watts. All right, last problem. Refraction. What is the index of refraction for this glass? Snell's law of refraction. Looks like this. Filling in the values, N1 is 1, sine of 60 equals n2, that's the unknown, times the sine of 50. Looking for n2, we better divide both sides by the sine of 50. So that means I just need to divide the sine of 60 by the sine of 50. So sine of 60 over the sine of 50. 0.866 divided by 0.766 is 1.13. And 2, if the angle of incidence were 30 degrees, the angle of refraction, I've got n1 times sine of 30 equals that n2 I just found times the sine of the angle of refraction. The angle of refraction would be the inverse sine of sine of 30 over 1.13. That would be 0.5 over 1.13. Take the inverse sine, that's 26 degrees.